Good evening, madam. My name is Johnson Lee Chong, and I am from RY32 Group 1. So now I'm going to present my 4 questions for the lab test. So for question 1, as you can see, this is my coding. So I have, based on the question, I have already list down my X and H. So for the X, the range is from 0 to 5. And because of that, I need to put the X -1 at here because the system detect that my range is from 0 to 6, so I have to put the negative one at here. And so this is the subplot of my X, and I put the stamp for at here for the N1 dot dengan X sebab kita guna discrete time signal, so kita guna stamp. So and I put the title XN. So for H, saya pun kena letak juga negative 1 kat sini sebab yang sistem dia pun detect my range for the H is from 0 to 3, 0 to 4. So I have to put a negative 1 at here to let my range is from 0 to 3. So this is my subplot for the H, and also it's because of discrete time signal, so I have to put stamp and then in title, and then the convolution for X time H. Okay, and then this is for the Y, and then read on also. Let's see the result. So as we can see here, this is the result for the X and the H. So for the X, we can see that at the first one is at positive 1, the second one is at negative 5, and the third, fourth, and fifth one is at the 0 point, and the sixth one is at the 0.6, at the 0.1. So for the H value, the first value is at 1, the second and third value is at 0, and the fourth value is at negative 1. Okay, so basically it's same as the value I put in the MATLAB. And so this is the YN for the XN dot dengan H convolution. Okay, that's all for the question 1. So for the question 2, and here based on the question, I already list down the value for A and B, and then I put the transfer function for AB. This basically it convert the A and B into the transfer function, okay? And then I put the RPK is equal to residual AB. So that means it will find the residual O and the direct form of the partial fraction expression of the ratio of our A and B. Okay, so another one is seems equal to ZPK. It means that the ZPK is mean that it uses ZPK to create a zero pole gain model. Okay, and then the sims as it basically means that I give the system know that I let the character as axis. Okay, so and this is the calculation based on the Solana, and this it means that I want to find the Laplace of ft by using the name of fs, and this pretty fs mean that at the command window we will see the result of fs. Okay, let's see the result. So here we can see the result for the fs is this. Okay. Okay, that's all for the question 2. So let's continue question 3. So for the question 3, it's a little bit confused for me for a while because I don't know how to convert this type of formula into the partial fraction. But after I already find out the answer, I can use it as to define the numerator and the denominator like this. Okay. After that, I also use the transfer function to let my numerator and denominator as a transfer function. And then same for the RPK to find the residual pole and direct term or partial fraction expansion of the ratio for numerator and denominator. Okay, so this is also the same as the above. And this I let the system know that I use the character T for this coding. After that, for this poly to sim number T divide with poly to sim denominator T, it means that it use the T the var T to create the symbolic polynomial expression ft from the vector of coefficient numerator and denominator. Okay, so yang ni lagi senang. Okay, more simple than like typing on the coding for like this is the most simplest way for us to make our calculation and not tambah tolak lagi lah, tak payah. So yang ni the most simplest way for the system to detect, okay, to detect our calculation. And this is like same. We will find the Laplace transform of ft by using the name of fs, and then we will find out the result of fs inside the command window. Okay, so yang ni untuk kita dapat kita punya SYS punya SYS punya plot diagram. Okay, so let's see the result. Okay, so this is the result for my question 3. As you can see, this is my pole 0 map. This one is my pole 0 map. And this is my board diagram for my SYS. Okay. And then let's see. Okay, so this is my command window for my question 3. Okay. And last is for the question 4. As usual, I also already list down the numerator and denominator for the coding from the lab sheet. And then this is also the RPK is equal to residual number denominator, same as the above. It's to find out the residual pole and direct term for the numerator and denominator. Okay, and this is to let the system know that I already create a character Z. Okay, and this is the calculation for the question 4. Okay, and this is to find out that our inverse transform of y. Okay, and this means that pretty y is to find out the answer for y, but instead of using y, we use the name of y z, and this instead of using the small y, we using the small y n. Okay, and then this the last one is to find out is to show out the diagram of the numerator and denominator. Okay, let's just see the jawapan. Okay, so before we see the plot diagram, we need to know if either our shade region is from outside or inside. So we can see it in our command window by looking at the pole. So as we can see in the pole, we have -4 and -2. So if n is less than, if the pole is less than 0, that means it's at the outer side of the circle, and it means that this is a causal. This is a causal diagram. Okay, so let us see back in our plot diagram. As we can see, if we draw outside the circle, like this is the shape diagram. Let's start from -2. Okay, this is a -2. We want to draw the shade region. We not draw in the inside of the circle, but instead of it, we draw outside of the circle. Okay, we draw outside because this is a -2, and it means that we need to draw the shade circle outside. Okay, and for the -4 is also we need to draw the -4 outside the circle. So that means the -2 and -4 is both outside from the unit circle, and that means this is a causal plot diagram. Okay, this is a causal plot diagram. And to know that if this plot diagram is stable or not stable, the answer is not stable because the plot are not inside the unit circle. Okay, if the plot is inside the unit circle, then this plot diagram is very stable, but this is not a stable plot diagram. Okay, so that's all for my assignment. Thank you, madam, for watching this video. Okay, thank you.